Enter the void.
If you haven't heard yet, our solar system has a new visitor, and it's not ordinary. In July 2025, astronomers identified a mysterious interstellar comet, 3I Atlas, discovered thanks to the ATLAS survey telescope in Chile. It has sparked global attention. But amid the hype, what do we actually know? Join me, and let's cut through the sensationalism and dig into the real science behind this cosmic wanderer. 3I Atlas was first spotted. Only about 4 scientific papers mentioned it. Now, just months later, there are nearly 70. That explosion in data reflects rapid progress in observation and theory. But first, let's rewind and recap what we knew about it when it entered the spotlight, and how it compares to previous interstellar visitors. 3I Atlas is the third confirmed interstellar object to visit our solar system, after Oumuamua in 2017 and 2I/Borisov in 2019. It was discovered on July 1, 2025 by the Atlas Telescope network in Rio Hurtado, Chile. Its hyperbolic trajectory indicated it came from outside our solar neighborhood. From early observations, astronomers estimated its speed at approximately 58 kilometers per second, and its age potentially between 3 and 11 billion years. In contrast to its predecessors, 3I Atlas exhibited higher activity detected even from greater distances, a clue it's not a run-of-the-mill comet. NASA's Hubble Space Telescope imaged 3I Atlas on July 21, 2025, when it was approximately 277 million miles from Earth. The images show a teardrop dust cloud emanating from the nucleus, with the stars in the background stretched by relative motion. From that, scientists estimated its nucleus diameter somewhere between 440 meters and 5.6 kilometers, smaller than initial guesses when brightness was assumed to come solely from nucleus. Then, on August 6th, the James Webb Space Telescope turned its near-infrared spectrograph toward 3I Atlas. Researchers detected complex coma structures and varying outgassing behaviors. Carbon monoxide and carbon dioxide seemed more active at that stage than water vapor, unusual for comets this far from the Sun. Interestingly, whereas comet tails typically point away from the Sun, observers noticed dust moving even toward the Sun, likely because dust grains fragment as they drift, changing dynamics. On August 27th, Gemini South in Chile captured multicolor images showing the growing coma and the comet's tail, estimated to cover tens of thousands of miles. These observations reinforce that 3I Atlas is becoming more active as it approaches perihelion. In spectral observations, astronomers detected emission in the CN band, meaning the comet is releasing hydrogen cyanide, broken down from sublimating ices under solar radiation. At the same time, 3I Atlas appears to be carbon chain depleted, meaning it has less of molecules like C2 or C3 relative to CN. That aligns with observations of 2I/Borisov, hinting at possible shared formation traits. One striking advance. Astronomers located pre-discovery data in TESS images from early May 2025, before the object was formally identified. This allowed verification of brightness curves and early trajectory. When the comet moved from approximately 6 astronomical units toward the inner solar system, its brightness increased much more than expected, indicating significant activity at large distances. From TESS data, some periodic light curve signals appeared, but the signal was noisy. Ground-based telescopes lean toward a approximately 16-hour rotation. In September, polarimetric observations showed a deep and narrow negative polarization branch, reaching about minus 2.7% at small phase angles, unprecedented among comets and asteroids. This light scattering suggests the dust grains in the coma structure are unlike familiar comets. It might place 3I Atlas in a distinct class of interstellar bodies. One of the most intriguing findings, water vapor, was detected even when 3I Atlas was about 3.5 astronomical units from the Sun. That's relatively far for water sublimation to occur. The estimated water production rate suggesting an active area of the comet's surface may be approximately 20 square kilometers or more. On a more speculative note, astrophysicist Avi Loeb and collaborators have posited controversial ideas that 3I Atlas may not just be a natural object, but possibly engineered or of technological origin. Their arguments rely on revisiting older size estimates, orbital dynamics, and lack of non-gravitational acceleration. Critics counter that later measurements reduce the need for exotic explanations. They argue the data is consistent with cometary physics without invoking extraterrestrial tech. 3I Atlas will reach its perihelion, closest point to the Sun, around October 30th, 2025 at approximately 1.4 astronomical units. At closest approach to Earth, it will still be well beyond dangerous proximity, about 1.8 astronomical units. During perihelion passage, the comet will briefly be hidden behind the Sun from Earth's view, but observations may resume afterward. Future observers include space telescopes like Hubble, JWST, and missions orbiting Mars, ExoMars TGO, may capture additional data. As this visitor recedes, many mysteries remain. How will its activity change? Will it break apart? Can we trace its parent system? 3I Atlas is racing toward the Sun and then back out into interstellar space, leaving us a rare chance to study matter from beyond our solar system. Stick around. The dust hasn't settled. I can't wait to see what astronomers uncover next. If you learned something new, hit like, subscribe for more space mysteries, and drop your theory below. Was it a comet or something more?